I'm going to show you to begin with. First thing I'm going to show you is how we can label a right-angled triangle in accordance with trigonometry. After I've shown you labeling, we're going to look at the relationship of the trig ratios firsthand. Now, first thing we're going to look at is this triangle over here. This triangle is a right-angled triangle because it's got a right angle over there. Now, when we were doing Pythagoras' theorem, we identified our right angle, and opposite the right angle in a triangle, Harry, what did we say that side length was called? It starts with H.
I'm trying to remember.
Juju?
Hypotenuse?
Hypotenuse. We always label the side opposite the right angle the hypotenuse. Now, when we're dealing with trigonometry, we call it H. Some textbooks call it little h. It's up to you if you want to do big H or little h.
What's the difference?
One's a capital and one's a lowercase. In terms of the math involved, it doesn't make a difference. I prefer to use the uppercase because it makes the O a little bit simpler. Can you put that away, please? Second thing we do is we look for the angle that we are given in a triangle. We're going to give this a strange name. The letter comes from the Greek alphabet. It's called theta. It's spelled T-H-E-T-A. In the Greek alphabet, it makes a sound.
I've got no idea.
What does it say?
Theta.
So
Theta.
T-H-E-T-A.
T-H-E-T-A. Makes a sound like the, there, they.
T-H-A-T-T-A.
Now, this is called our...
T-H-A-T-T-A.
Are we good? Alright, focus. 2 eyes, 2 ears. Opposite the angle of interest, which we call theta, we get a side. This side is called the opposite. Why is it called the opposite? Because it's opposite the angle of interest, theta. And then we have a side left over. This side is called A. A stands for adjacent.
Of this.
Now recall, the study of trigonometry relates the angle within a triangle to a ratio of its side lengths. We now have a properly labeled, or a fully labeled right angled triangle. What we're able to do with this is we're able to calculate ratios. Now, I know I've got this funny thing here and this funny thing here as A, I, and BI, but we're going to leave those for a little bit later. First thing we're going to do is we're going to look at O over H. If we look at our triangle over here, we see our opposite is 3 and our hypotenuse is 5. If I put or substitute 3 in for O and 5 in for H, then all of a sudden I get a fraction. Now if I want to compute this fraction, it is the same as saying 3 divided by 5. Now if we put 3 divided by 5 in our calculators, what figure do we get? So everyone needs to pick up their calculators and just type it in.
0.6.
What am I typing in, sorry?
Are you listening? 3 divided by 5 is
0.6.
0.6. Excellent. Now, our second thing that we're going to be doing is
I got error.
we're going to compute this. Just watch. A over H. Hands up, what is the value of A in our triangle? Conrad, your hand started going up to rest your head, but it was going up. What is A? It is T adjacent, which is 4. So it becomes 4 over, and our hypotenuse, Daytona? 5. So if we compute this, 4 divided by 5, we're going to get 0.8.
8.
Excellent. Now, let's hold on to these two values. What we're now going to do is we're going to turn to something unfamiliar. Looking at above, we have sin theta. We don't know what sin is, but we do know what our theta is. Our theta is 36.9. So if I change this expression to something more familiar, we get this guy over here. Sin 36.9. Now, here's the sort of useful thing, sort of not useful thing to you guys yet. We need our calculators to be able to compute these. So I go over and I load up my calculator. Now, on your calculators, first thing you always need to do when you enter a math classroom and you're about to do trig is you look for the reset button and you press it. You will probably need to use the tip of a pen or the tip of a pencil to do this.
Why?
The reason you do this is there are multiple ways in which you can measure angles. Because you're at a school with shared calculators, you don't know what the person before you was doing on it. For all you know, they were a monkey pressing at the buttons and they set it to radians or they set it to gradients or they set it to God knows what.
I was the last one on this one.
What you want to do is you want to press the reset button. This will set the calculator back to its factory settings. Next, we're ready to do our calculations, guys. Feet. Along the top function row here, we have sin, cos, tan. We want to know sin 36.9. So I press the sin button, I open up the bracket, and I go 36.9. I then close off the bracket. So you should all be holding a calculator and type those keys in.
Where's sin bracket?
Once you've typed it in, we're going to press the equals button. And
Close bracket.
what do we get?
0.60.
0.60 or
0.6.
0.6 to 1 decimal place.
So Nathaniel broke his calculator.
Let's make the comparison. Press the reset, try again.
Press the reset. Oh, fixed.
So I can't click mine.
What's radio saying?
That's awesome. Okay, now, everyone's eyes and ears. We're about to make the connection. Close it up. Jamin. Come on, I need everyone's eyes and ears. I've never met someone who has learned all of trigonometry just by listening to an audio
I
book.
have. You're going on audio box. I have now.
You didn't make the connection there either, did you? Okay, make the comparison.
Do you need to?
For the opposite over the hypotenuse, we got a ratio of 0.6. When we type in sine of our angle of interest, so sin 36.9, we also get basically 0.6. What is the relationship here? Yeah, the sine or the sin of an angle is going to give us the ratio by dividing the opposite by the hypotenuse. Now, if we go one further and go over here to this cos of theta, I substitute in my theta, 36.9 degrees. Again, if this is our first time using our calculator, we press reset, but you guys don't need to because you've already done it. We type in cos, like a cos lettuce, 36.9, just like that. We press equals and have a look at what we get. 0.799684, basically 0.8.
You have to round 7.
Round it to 1 decimal place, you basically get 0.8. So what you in fact discover is that
Wow.
sin
I wish
of
you could round stuff on the computer. On the computer.
theta is the same as opposite over the hypotenuse, cos of theta
It was a reset button. It wasn't.
is the adjacent over the hypotenuse.
Muscular.
It kind of makes sense.
It's not going to make sense, it's just going to be things you know.
Okay.
Not everything has to make sense.
Is this camera even recording you, sir?
It is. This won't make sense until you choose to do Year 10 Advanced in second semester of next year. Otherwise, it's just going to be something you know. Okay, so what we discover is that there are ratios. Sine or sin of theta equals OH. Cos of theta equals A over H. Now, what these are called the trigonometric ratios. I'm just going to shorten it to trig ratios. Basically, we have three of them. We remember them using a mnemonic, which I'll get to in a bit, but our ratios are sin, oops, it's a bit messy. Sin of theta is opposite over our hypotenuse. Cosine of theta is our adjacent side divided by our hypotenuse. And there's one more for now.
Is it tan?
Tan. Tan of theta is our opposite divided by our adjacent. This is sine, S-I-N-E. This is cosine. This is tangent. The tangent refers to a line that touches another line in one location only. Or sorry, it touches a curve in one location only. The cosine refers to the co-partner to sine, and sine refers to a mistranslation from an Arabic book thousands of years ago. The way you remember these is, we say so, ka, toa. Whenever we have the opposite and the hypotenuse, we know to use sine or sin, whatever you want to call it. Whenever we have the side length, the adjacent, and the hypotenuse, and an angle, we know to use cos or cosine. And whenever we have the opposite and adjacent, and an angle, we know to use tangent. If you have multiple, then you can choose whichever one you want. But there's always, for year 9 math, one of these is missing. You're either trying to find the angle and you know two sides, or you're trying to know a side and you know a side and an angle. But basically, this is the knowledge you need to be able to do trigonometry, guys. This. Label mnemonics. Are there any questions?
No.
Okay. What you're going to do, guys, is familiarize yourself with your technology today. Familiarize yourself with labeling a triangle.
Wow.
Question 1. It says compute. Compute means write down the expression, pick up your calculator, type in what you see.
Is that what I see in bracket?
That is pretty straightforward if you know how to use your tab.
What's after the 30?
Next. It says consider. My other class got very confused when it said consider. It said consider the triangle and they're like, I don't know what to do, and I'm like, consider it's there. Go down. You see in bold, there is the verb. Calculate the following. Sin theta. What could theta be here?
22.6.
22.6. So sin 22.6. Calculate it. O over H. O is 5, H is 12. 5 divided by 13. So question 2, you're just calculating, just like you did in question 1. Next, label the right angle triangles. What is always opposite our right angle? Hypotenuse, or the hot potato, or the hippopotamus. Hypermaximus. And then, what is always opposite our angle of interest? What is opposite the angle of interest?
Opposite.
The opposite side. What is the final side on a triangle called?
Adjacent.
Adjacent. So you just need to sketch these in your book. No rulers allowed. You're going to sketch freehand-it, and then you're going to label it. Why do I need you to freehand it? Because I want you to get better. And then, final one, it says, the tide at the jetty goes up and down. The height of the tide can be modelled with the expression as shown here. 3 sine 30 t. T represents the time of day. So if we are at 12 in the morning, so the day has just started, the time is 0. So it's going to be sine 30 times 0. At 3 in the morning, the time, or t, is going to be 3. So you're going to go sine 30 times 3.
Like a 24-hour clock?
Just like a 24-hour clock. So when you have 4 o'clock in the afternoon, it's going to be 1600 hours, or 16. Using this calculation, you're going to determine the height of the tide. I'll give you a hint. It's either 3 meters above sea level, or it's 3 meters below sea level. Because the tide goes in and it goes out twice a day. And then finally, there is some show, but if you get up to this, I'll give you a demo on how to do it at your desk, because not many people get up to this, and it's not too important. Alright, are there any questions, guys?
Are we doing this for the rest of the lesson?
This is our challenge. We need to familiarize ourselves with our calculators or our tech, and we need to be able to familiarize ourselves with labeling a triangle. Izzy, is this related to the learning?
Can I please go just hold my drink bottle, please?